Hi, welcome back to your new lesson. This is Lakshmikant Tiwari. In this lesson, I'll be taking you through a Pandas crash course, and I would first suggest you to take my Python crash course tutorial. If you do not know about the Python, it would be very easy to learn Pandas if you first go through the Python. The Pandas package is the most important tool at the disposal of the data scientists and the analysts working in a Python today. The powerful machine learning and glamorous visualization tool may get all the attention, but Pandas is the backbone of the most of the data projects. If you are thinking about the data science as a career, then it is imperative that one of the first things you do is learn Pandas. In this video series, we will go through the essential bits of information about the Pandas, including how to install it, how to use it, how it works with other common Python data analysis packages such as matplotlib and the Scikit-Learn. But before using the Pandas, we need to understand the capabilities of the Pandas, what it can do. It can do almost everything. It can do almost every signal processing algorithms on any type of the data which you might have in the form of the CSV file, in the form of Excel file, in the form of the JSON file, or any other kind of the data files. Such as you can do the statistical analysis like calculating the average, mean, max, mean of column or rows. You can do the correlation between the columns and the rows. You can understand the distribution of the data in a column and rows. You can do the cleaning of your data files like removing missing values, outliers, filtering rows and the column by some criteria like by applying some logical or mathematical function. And finally, you can do the data visualization with the help of the matplotlib library using a plot bars, line bars, line plot, histogram plot, bar plot, bubble plot and other kind of the plots. And then finally, once you have your clean data, then you can transform this data and then finally you can write back into a CSV file. There has been a popularity rise into the Pandas in last few years, especially in last 6 to 7 years. Pandas popularity has been growing exponentially amongst the data scientists, and this Pandas has been almost the first choice amongst the data scientists and machine learning enthusiasts. Okay, the Pandas is built on the top of the Numpy package. That means the structure of Pandas is similar the kind of the Numpy, and data in the Pandas is often used to feed statistical analysis into a SciPy, plotting function from matplotlib and machine learning algorithm in Scikit-Learn. That means if you know the Pandas, then this is going to help you in learning your machine learning. Machine learning, basically we use Keras with the TensorFlow backend, or we use Scikit-Learn. So especially Scikit-Learn we use for classical machine learning, and for deep learning we use TensorFlow. And we can do this programming in so many other IDE like PyCharm, and the Sublime Text, Atom, or the Jupyter Notebook, right, or Visual Studio. So here in this video series we will be doing with the Jupyter Notebook, and Jupyter Notebook offer a good environment for using Pandas to do data exploration and the modeling. And we can download this Jupyter Notebook with our Anaconda. You need to go to the anaconda.com and then download Python 3.7 version. Since I have a Python 3.7 version, I would suggest you to also download Python 3.7 version. I have already downloaded this Anaconda and I have already installed it. So once you install the Anaconda, it automatically install your Jupyter Notebook and most of the Python libraries like Numpy, Pandas, SciPy and other kind of the Python libraries which you use in general in our machine learning and data analysis techniques. Okay, Right, so let me show you how you can do this. So you need to type here the Anaconda, and then I would suggest you to start it as an administrator. So once you start it as an administrator, it will open into Windows System 32 directory. Then you need to redirect it where you are intended to save your programming files. So I have created here a new directory which is Pandas crash course. So I am going to change my working directory there. Once I have changed my working directory there, then I need to write here Jupyter notebook. Okay, perfect. So once I have a Jupyter notebook, then it will run a local server on my computer, and finally it will open a local server on my preferred web browser. In this case it is a Google Chrome. Okay, finally once you have this Jupyter notebook open, then you can create here, either you can upload here new files, or you can create a new file here. So let's create a new file, and then I am going to rename it as a Pandas crash course. Okay, right, and I would also tell you some shortcuts of a Jupyter notebook. You need to press a keyboard H. Once you press H, it will open a keyboard shortcuts, and here you see F is find and replace, and P is open the command palette, Y is change cell to code, M is change cell to the markdown, and 1 with the change cell to the heading 1, and 2 for heading 2, 3 for heading 3, and 4 for heading 4, and so on. Right, so basically I'll be using mostly like A, insert a cell above, and B, insert a cell below, and X to cut the cell, and C for copy the cell, and V for paste the cell, and Z to undo the selection. Okay, perfect. So what is the best way to start the Python, start the Pandas coding? If you don't have the Pandas, then you can install it either with the code install Pandas or pip install Pandas. Since I have already installed it via Anaconda, and of course once you have installed your Anaconda, the Pandas will automatically come installed on your computer. Right, so let's start our Pandas coding. So first you need to import your Pandas package in your Jupyter notebook, and you can do that with import Pandas as PD. This is most preferred way. And to execute this cell, you can do it into the 3 way. First is shift and enter. If I shift and enter, you will see here there is a star mark, and that star mark says that this cell is being executed, and server is not available to execute another cell. Right, since I had pressed shift and enter, so this cell was executed and new cell was created. And let's say if I cut this cell by just pressing X, so if I press X, this cell will be cut, and if I execute this with the control and enter, then you will see here it will execute this cell, but it will not enter into a new cell. Okay, so the best preferred way to go with shift and enter. Okay, right, so now we have our Pandas in the form of the PD. If we write here the PD and a dot and just press a tab, if we press a tab, you will see here there is a circle, filled circle. That's mean the kernel is busy. Okay, the kernel is busy, and the kernel is indexing and the finding out the suggestions, what are the other things which we can be applied on the PD dot. That's mean these are the things which we can do, like pd.api, array, arrays, categorical, compat, concat, core, etc. There are so many things, data frame, data offset, date times, error, etc, etc. All those things can be done. Right, like reading the SQL, reading stata data, reading JSON, HTML. Right, so these kind of the things can be read, or these thing or the files can be written into the date time, CSV, etc, etc. Okay, so what are the core components into the pandas? Those core components are the series. If I write here the series, there would be a series, and the data frame. Okay, so these two are the core components. So we can do with the comment here, series and data frame. So these are the core components into a panda, right? So we can create series and the pandas. So how we can do? The very simplest way to create a data frame or a series from a scratch into a pandas by using just a dictionary in a Python. So let's create a dictionary here, data. Okay, if you remember a Python coding, we have three kind of the bracket. The first is a curly bracket, then there is a parenthesis, and then there is a square bracket. Then curly bracket shows that the dictionary. Now we have here the curly bracket, and in the curly bracket we need a key and the value of that key. So let's say here I have a first key like apple. Okay, so this is the key, and how many apple I have? I have, let's say, the 3, 1, 2, 4 and 5, right? And then another I have orange, let's say. Okay, so in orange is a key, and in this orange key we have a value, that is the list of the value, and here I have a 1 and then 5 and then I have a 6, and let's say then I have a 8. Okay, so just shift and the enter. I have run this execution, and let's print this data. I have here the data, that is the apple and the orange, and if I print a type of this data, then you will get it dictionary type, right? So once you have this, then what we can do, we can create the data frame by this. So how we can do? We can just write here the data or the data frame like a df is equal to pd dot data frame, and then I can pass this data, then we can execute this, and finally we can print this df. Now you will see here, this is the index, and here we have apple and here we have a orange, right? And earlier I have talked about the series. So if there is only one column, then it will be a series. So that means we can print it using like this. If I type here the df and apple, then you will see this is a series. How we can know this is a series? We can write here a type and df and then apple. Okay, you see this is a series. Okay, that means if it has a 2 column or more than the 2 column, then it will be always a data frame. But if it has 1 column, then it could be a data frame or a series. Okay, now let's start working on the real data. Okay, so how we can do a real data? We can download a real data. You can download a real data from my GitHub repository. You can visit here github.com ml data files. Then you can copy this ml data files. Okay, you need to either you can download it into a zip file. If you already have a Git installed in your computer, then you can clone it. Okay, if you have installed it, you have downloaded it, let's extract this data file. Now we have this data file. Let's just copy this. We are going to copy it and we are going to paste it into our working directory here into Pandas crash course. Right now we have into our Pandas crash course. Let's see it here. We have it here. See, okay. Now I am going to tell you how to read CSV file. Okay, right. So let's introduce first some columns so that we can work very comfortably. Here you can just press B, it will insert a lot of the rows behind your working rows. Okay, perfect. Now we are going to read the CSV file into a data frame. So we are going to read it into the DataFrame dfpd.read. Once we write here the read and press a tab, it will automatically suggest you what are the types which it is going to read, like CSV, Excel, Feather, FWF, or what kind of the file we have. So here we have CSV file. So we are going to read a CSV file here. Okay. So once we have CSV file, now we need to mention here the name of the files. Okay. So let's say here we have so many name of the file. We are going to first read here the NBA. NBA is a football team. There we are going to read here the NBA and press a tab. It will automatically fill it. Now we have our data frame. The data frame, if we just write here the data frame df, it will try to print first 30 columns and then finally last 30 rows. Sorry, first 30 rows and then last 30 rows, and then there is, you see here the dot, that means these in between these two rows, all others rows has been skipped. And you can see here it has 1 2 3 4 5 6 7 8 and the 9 columns. Okay, now let's say if we want to just print a few first rows, okay, that can be done with the head. If we type here head, by default head takes only 5 rows, and if you press if you place your cursor in between these parentheses, and if you press shift and the tab, you will see here it takes by default n is equal to 5, right? And if you press shift and double tab, it will automatically expand the documentation of a head, and you can go below here and you can understand it into a little bit more detail. Okay, so if you type here 1, it will just print 1 row. If you type here 0, it will not print any row. If you type here 10, it will print here first 10 rows. Now you might be wondering that what is the technique if you want to print last 10 rows. That is, you can print with the tail method. That's mean df.tail. By default df.tail take 5. That's mean it will print last 5 rows first. And if you type here 1, then it will print last row. And if you type here 0, then it will not print any row. If you type here 2, then it will print last 2 row present in your data frame. Right? Now one more thing, let's say if you have this type of the data frame and you want to make this name as a index, right? So here you see the index is by default 0 1 2 3 4 kind of. Let's say if you want to make an index this name, then how you can do? Either you can set an index or you can read your data frame by default as an index this name. Okay, so how we can do that? We can write like df then pd dot read into CSV, and then we can take nba.csv, and if we press here shift and tab, then you will see here there is a lot of the suggestions. Okay, so here we have index column. We need to write here index column. Okay, index column. So index column we have a name. Okay, so if we type here name and let's take here df head, now you see here the index column has become this name. We can do the index column of anything like team, number, position, etc., whatever you like. Okay, so this is the way how we can set a index. Okay, perfect. Now let's go ahead and what are the other now let's go ahead and let's try to do some other most important data frame operations, like viewing the data, analyzing it, and etc. All those things. So for that things I am going to do with the IMDb movie data set. So let's load that movie data frame. We can do with the df, and then of course pd dot read csv, and then we have here IMDb movie data set, and then we have index underscore column is equal to, okay, I'll show you that later how we can do. So once you load this, and if you print here df.head, you will see here these are the 5, see here 5 rows has been printed. So let's say if I want to set my index the title, right, or a rank. So what we can do, we can write here index call is equal to title. Okay, now the title has become an index call, or we can set here rank. Okay, see here the rank is now the index column, and others are non-index column. Okay, perfect. Now let's say if you want to see the last 5 or 10 rows of your data frame, then of course you can use del, then it prints last 5 rows 996 to 1000. Perfect. Now apart from this, let's say if you want to do a little bit more, if you want more information about the data frame, then how you can do, the df.info, right? So it will print the information about your data, like you see here. It provides you essential details about your data set, such as the number of rows and the columns, the number of null values, what type of the data is in each column, and how much memory your data frame is using. If you see here, this is a non-null object, this is object, and the year is int 64 type, runtime is here minute 64, this is the float 64, and this is int 64, and this is a float 64, right? And the data frame is more than 93 KB, that means it is taking a memory around 94 kilobyte in my computer. Like, now let's say if you want to understand the shape of your data frame, you need to write df.shape. That means it shows that there are 1000 rows present in your data frame and 11 columns in your data frame, right? Apart from that, what is the use of this shape, right? So you will be going to use this shape a lot when we will be working with the cleaning and the transforming of the data. With this shape, we can understand how many rows or the column has been removed because of the duplication. Okay, now let's try to handle a duplicate. How we can handle this duplicate? What we are going to do here, we are going to first see if there is any duplicate. So how we can do that? We can do just df.duplicated. Okay, so if we see here, it will say that if there is any duplicate in any rows. So it says that there is no rows which has a duplicate. Okay, and if we say here a sum df.duplicate, it will print if there is any duplicate. That means there is a 0 duplicate. Okay, now let's say if we have df1 where we do df.append. Okay, df, right? And then we have a df1.shape. You see here now we have 2000 rows. Earlier we had only 1000 rows. That means what we had done, we have stacked data frame df, one df on another df. That means there is 1000 duplicate rows. Now how we can understand how many duplicate rows? With the same methods, sum df dot duplicated, right? So it says that there is no duplicate, right? Now let's see how many duplicate columns are present into a df1. Okay, so how we can do here, df1 dot duplicated, and then we are going to apply a sum, and it says that there is 1000 rows are duplicated into a df1, which of course we know that there is 1000 rows which has been duplicated. Why 1000 rows? Because I had added df with another df. That's when there is a one df, and then I had appended and the same df into df1. Then how we can remove this? Let's say if we want to store a new data frame into df2, then how we can do? We can write here df1 dot drop. If we type here drop and press a tab, it will suggest you drop duplicates and drop NA. NA means not number, and drop duplicates. So here you will see it will automatically drop all the duplicates, right? And now if we see here df2 dot sep, then you will get it again 1000 into 11. But at the same time, if we say here df1 dot sep, we will see here 2000 into 11, right? 2011, right? There are so many other things we can do with the duplicates. If you place your cursor inside those parentheses, and if you press shift and tab, you will see here the documentation of the duplicate. This says that there is the keep, okay, and that is the first. That means it will keep just the first duplicate and it will remove other duplicates. And then there is in place, which is a false. Okay, in place means, let's say if I say here df1 dot drop duplicates, okay, it has dropped the duplicate. If we check here a shape, you see here it has dropped the duplicate. But if again I check here df shape, it will say that 2000, okay, because in place is not true. If I say here in place is true, then if I execute it, okay, just remove this. If I execute this, you see here now the df1 is 1000. That means it has dropped the duplicate and it has placed a new data frame into a df1. That's when df1 has been now modified. Okay, perfect. Now let's understand how we can do a column cleanup. Now let's add few more cells here to make it comfortable to work with this. Now let's work with a columns cleanup. Okay, you see here, let's see here df, how we can print a column, just df dot columns. Now you see here we have here a column, these are the columns, and if we try to print here length, how many columns are there, then you will get 11. Okay, so the df dot columns, you will see here the columns. If you want to get more information about this df, type here df.describe. You will get other kind of the statistical analysis of a df. Okay, now let's save this df.columns into a list. Okay, so that list is call, and if we print here call, this is a list. Okay, and if we see here the type, this is kind of the index list. Okay, either we can convert this into a list here. Now if we see here type, okay, see here, this is the list. Okay, so here we have a call, that is the title, genre, description, director, actor, year, runtime, rating, odds, revenues, and meta score. Right, now what I am going to do here, I am going to rename these columns. Okay, how we can rename these columns? There are two things, there are two ways. Either I can provide here, let's say this is the call and here this is a call one. Okay, either I can set the column with new list, or we can rename the column. So here I am going to set the column with the new list. Okay, so the new list is just a very random list. Here A, then we have a B, then we have a C here, then we have a D, E, and then F, then we have a G, then finally total here 11 columns. So we need 11 column, 1 2 3 4 5 6 7 8, right? And now we need few more, H, I, J, and here we have a K, right? So what we are going to do here, we are going to here type here df.columns is equal to call 1. Okay, now let's print this df. See here, now new column of the df is this, right? Now let's again set the column, a previous one, okay, which we already have into our call. Now we have a df head, same as the previous one. Okay, perfect. Now we are going to apply another method, that is the rename. Okay, so how we can do that rename? We can do the df dot rename. If we press here shift and the tab, we will see here what type of the mapper which we are going to use. And we are going to use a columns rename. Okay, you see here you can get the parameters. Okay, so I am going to use columns is equal to, in the form of the dictionary, then there will be a key and the value. Okay, so I am going to rename, let's say I am going to rename, let's say, this runtime minutes. Okay, so just copy it. Now we have copy, and then what I can do, I can paste it here. Just paste it. Of course I need to place it into a single column. Okay, and then we are going to change it with the just runtime. Okay, and then another key which I am going to change here, that was revenue, sorry, that was revenue. Okay, and which was written into millions. Okay, just I am going to make it revenue, and then finally I am going to make here in place is equal to true. Just run it, and let's say here now df df.columns. Okay, now you see here we have here call the previous column, and this one is the new column. In the previous column we have revenue into the millions, but here we have just a revenue, and we had a runtime minutes, but here we have just a runtime. That's mean here we have learned how we can modify column into two ways. Either we can provide a new set of the column, or we can rename columns with their respective keys and value, right? Perfect. Now let's go ahead and try to understand how we can work with the missing values. Okay, that is a NaN. Okay, so if we type here, then if we try to work with the NumPy, then of course we have to first import NumPy. So let's say first I import NumPy as np. Okay, if we type here np NaN, then we see this NaN, that is not a number. Okay, so that's mean any kind of the number which cannot be represented in any number, that is the NaN. That could be either infinite or just a NaN. Okay, so let's say if there is any null value or NaN into a data frame in our movie data frame, so that is the df dot is. If we place here is, there is three kind of the suggestion: is in, is na, and is null. So we are going to check here is null. Okay, so just shift and the enter, and then we have here the title, genre, description, director, actor, year, etc, etc. Now it is saying that so many things false, 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 false. So with this I don't think we can find out that very easily if there is any true value. Yes, here, right? So these are the few things where there is null value present. Okay, so if we want total number of the sum, how we can do? df dot is null. Okay, and then we can do sum. It says that revenue has 128 column 128 rows as a null, and meta score have 64 rows as a null. Now we need to work on this one. Okay, similarly, if we do the drop NA, then it will automatically drop this rows, and the total number of rows will be reduced. Okay, let's say if we work with the NA, so each NA, right? So each NA dot sum, similar kind of the results now we are getting, right? So either null or NA, in both way it is right. Okay, perfect. Now what we can do, we can take it into the new data frame df1. Let's say the df dot drop and NA, that's mean not a number. And if we do like this, and again if we do the df1 dot shape, you will see here the 128, right? And plus, of course, if that is not included here into this meta score, those number of rows has been discarded. So that is the 1000 minus 838, that is total 162 rows has been discarded, right? So that's mean total the data set size has been reduced. But there are other way where we can work, like let's say there is revenue, either we can fill a mean value of that column in that revenue, or we can fill a 0. Okay, so we can work in that way as well. Otherwise what we can do, we can drop this revenue column instead of just dropping those rows in which this has a the null value, right? So let's say if we want to drop the column instead of those rows, so we can do into the df2, then df dot drop NA, and now we need to work along the axis 1. The axis 1, that means the column. Okay, and now let's say here df2 dot head. Okay, so here we are just going to see just 3 value. So here now you see we do not have revenue and meta score, and if you count it, there would be only 9 columns. 1 2 3 4 5 6 7 8 9 and 10. Sorry, there are total 10 columns. Okay, yes, so earlier we had 12 columns total, and of course I had not included this rank because this is now has become an index, right? So this is the second way how we can drop. Either we can drop rows or we can drop a column, right? Perfect. Now what we can do, since now we can fill this the not number with some value. Okay, so that is df3 is equal to df dot na. Okay, sorry, dot fill na. Okay, so that is the fill na, and I am going to fill that df with 0 value. Okay, now let's say if df3 have any null value. Now you see it do not have any null value, since all null value has been filled with the 0. Okay, perfect. So this is the very crude way to either remove a null value or fill a null value with some kind of just a 0. Okay, so there are some other methods which we are going to discuss, how we can fill this null value in a proper way so that it should not affect overall the data. So let's first introduce, let's first add a few rows here, data cell, just by pressing B in your keyboard, so that we can work rightly, right? Perfect. Now imputation, right? So what is the imputation? One more thing here I am going to tell you. You need to press M on your keyboard. Now you will see here this cell has been changed to the markdown. Then I am going to press here a 3, that's mean third level of the heading, and then I am going to write here imputation. Okay, perfect. So now I am going to do the imputation. Imputation is the conventional way to introduce the feature, or you can say that imputation is a conventional feature engineering technique used to keep valuable data that have null values. There may be instances where dropping every row with a null value removes too big chunk of data. So instead, we can impute that null with another value, usually the mean or the median of that column. Let's look at the imputing the missing values in the revenue millions, which we had earlier. df dot is null, right, and sum. So in revenue we have 128 rows which has a null value. So we need to first take this revenue into a new variable. Let's say the revenue is equal to df, and then here we can take df and then revenue. Okay, so our column, the column is yes, of course we have here this column is revenue. Okay, so now we have new the revenue into new variable, which is a series. Actually, if you check it's a type, revenue type, that will be a series, Pandas series. Okay, perfect. And the head, tail, etc. other pandas, some pandas, the methods work on the series as well. I mean Pandas DataFrame methods work on the series as well. Like a head and the tail, we can do the revenue dot head. So you see here the rank, and then we have here, and similarly we can work with the tail. Then there is NAN, and here is NAN. So with the imputation method, we are going to fill these value with the mean of this revenue. Okay, so what is the revenue mean? We can get by calculating the mean of the revenue. So the revenue dot mean, and if we print this revenue mean, we will get 82.95. okay, so that is the revenue mean. Now we are going to fill that NA value with that revenue mean. Okay, perfect. So now revenue mean has been filled with the revenue NA, not number value, into revenue has been filled with the revenue mean. Now let's check the tail. See here, 82.95 is a mean value, and 996 rank movie has been filled with this mean value, and 999 has been also filled with 82.95. If we again check here revenue dot tail, we will again get a NAN, right? Why? Because we have not yet made in place true. If we press here shift and the tab, we see by default in place is a false. That means if we write here in place is equal to true, if we write here in place is equal to the true, then we can see here revenue has been filled with the mean of the revenue. Okay, now let's see if there is any null value into the revenue. Is null, and then finally submit. Now we have a 0. Now what we can do, now we can replace this revenue, okay, this revenue column with this new value which is revenue. Okay, perfect. Now once we have this, so let's again check our DF with null value is null dot sum. You see here now the revenue do not have any null value, but still meta score have a null value. So in the same way, okay, with the same procedure we are going to follow to remove the null value into our meta score. So for this we are going to the meta score is equal to df dot meta score, right? And then we are going to take meta score mean value is equal to meta score dot mean, and then I am going to fill this meta score, okay, meta score value, that's the fill NA with the meta score mean value, okay, and then I am going to replace this meta score with this meta score, right? And this meta score, once we have done this, then again I am going to check if there is any null value present into my data frame. So this says that, oh, is still meta, I think I have not made in place the true. Then of course I have to make here in place the true. Now you see the meta score has been also filled with the mean value, okay, and that mean value is I think we need to print that meta score mean value. That mean value is 58.98, right? Now let's see if we do the df.describe. What do you understand by this df.describe? This says that you get a summary of the distribution of your data, and it gives you the summary of only the number columns, okay? And those number columns are year, runtime, rating, odds, revenue, and the meta score, right? If we see here df.info, right? So you see here these are the only numerical columns. So numerical columns are the year, runtime, rating, odds, revenue, and the meta score. That's mean this describe only works on the numerical column, although information, this info works on all column, okay? This says that there is 1000 rows in year, runtime in every column. The mean of year is 2012 and the mean of runtime is 113.17, and similarly the mean of the revenue is 82.95. The standard deviation of these columns, minimum value in these columns, and the 25% of the percentile of this year is 2010, 50% percentile of this year is 2014, and so on, right? So this is the describe for whole data frame. Let's say if we want to describe the description about the sum column, then how it works, okay? So let's say we have a df.genre, okay? I think we don't have a genre here, right? Do we have genre? Let's see. Yeah, the genre, we have a genre there, okay? So df.genre, and if we say here describe, so genre.describe says that there are 1000 values, there are 207 values are unique, and the top repeated columns are action, adventure, and the sci-fi, and the frequency is 50, okay? Perfect. Now let's say if we say that the value counts, that's when, let's say if you want to understand how many numbers are there, okay? So how you can do that? How many numbers, how many different type of variables are there, okay? So df.genre, and then we need to write here value underscore counts, okay? So here we have let's say take just head, we are going to take head 10. So you see here action, adventure, sci-fi here, as you see 50 times. So similarly here 50 times. The drama has occurred for 48 times. Comedy, drama, and the romance was 35 times, okay? So this is how we can work with the value counts. Let's say if we work with the df genre and then unique, okay? So this represents all the this returns all the values which are just unique, okay? So you will not get any repeated value, okay? So if you see here, if you get the length of this, that is just 207. That means there are 207 unique values, okay, that we get from the unique methods, okay? Now let's say what is the correlation between these columns, and that can that we can get with the core methods. Okay, and that core method, that's the correlation. I'm going to press M in my keyboard and then 3. Okay, core method. The core method, that means will show the correlation. Okay, then that's mean if I say the df.core, okay, core met is equal to df.core. You see here now the core met. Let's print this core met. This is the correlation between these metrics. Okay, so of course year and year is correlated with the 1, and runtime and the runtime is correlated with the 1. Okay, so this is the correlation. That's mean if there is a high correlation in the positive, that's mean there is very high chance, like rating and the odds. Okay, that's mean there is very high chance if number of odds are high, then rating would be high. Okay, and also if number of odds are high, then the revenue will be high. Okay, there is very fair chance. Okay, and similarly there is a negative, right, odds and year. Okay, yes, so year and odds are the negative. That's mean in the recent movies, that's mean year, that's mean larger the year, number year, that's mean in the recent movies number of odds are less, that's mean it is the negative. Okay, and of course let's say if movies are released in last year, and if we compare the odds of the movies which are released 20 years ago, then the number of odds will be less. Okay, so that's the negative correlation. So this is how we see it into a matrix form, right? But there is so many other things where we can visualize this, like using matplotlib and matplotlib, right? We can use matplotlib. Perfect. Now let's see with the matplotlib how we can understand this. Before matplotlib, I think I'm going to plot this core mat with the Seaborn library. Okay, if you don't have a Seaborn, you can install that Seaborn. So I'm going to first import my Seaborn. Okay, Seaborn as SNS. Then I'm going to put here sns.heatmap and then core mat. You see here, this shows that correlation between year, runtime, rating, odds, revenue, and the meta score. This white value shows that there is a large correlation, and this black value shows that there is very less correlation. That's mean, or very less, that means in the negative correlation. Okay, so the correlation, negative correlations are very high in between odds and year. The positive correlations are very high in between the ratings and the revenue and the odds. Okay, perfect. Now let's say the plotting with the matplotlib. Okay, so we need to first import our matplotlib dot pyplot.hplt, and after that we need to do here matplotlib inline. Okay, sorry, perfect. Now what we are going to do here, we are going to plot we are going to plot a scatter plot between revenue and the ratings. Okay, see here, revenue and the ratings. So here is the revenue and the rating. You see here the revenue and the rating have a little positive correlation. That's mean higher rating will produce a better revenue. Okay, so we have here DF, and then of course we have here revenue. Okay, and then we are going to do the plot, and if we press here shift and the tab, then we can understand the kind of the plot. By default it is the line plot, although there are so many other kind of the plot, like line plot, bar H, histogram, box, KDE, density, area, pie, and scatter. So this is what we are going to use. Okay, kind is equal to scatter plot. Okay, on the x-axis we are going to give rating, on the y-axis we are going to give revenue. Okay, and in the data, of course we don't have a data, this will be on the df. Actually df dot plot kind, scatter, rating, xy, etc and etc. Let's see here, this is the plot. Okay, higher the rating, the revenue is increasing. See here, higher the rating, the revenue is increasing. Now let's see if we want to give x-axis and the y-axis value, how we can do. We can give here the title. See here, we have a title, we have legends, we have limits into the x-axis and the y-axis, etc and etc. Okay, so let's say we have a title here. We can set a title like revenue versus rating, right? The revenue versus rating. Perfect. And similarly, this is a scatter plot. We can do a bar plot. Okay, a bar plot of the rating. That's mean what is the maximum number of the rating, what is the distribution of the rating. How we can do that? That we can do the df and then rating dot plot, and then kind, that we have hist title is equal to rating. See, the rating, it is saying that the rating is not defined. This should be here like this, right? So this says that the total number of rating is around the 6 and the 7. So the 7 is, it's around the 7. So in between 6 and 8 there is very high number of ratings in our movies. Okay, so that we can identify with the df dot rating value underscore counts. Value underscore counts. You see here, if you see 7, most of the rating you see here, higher ratings are 7.152 times, 6.7 is 48 times, and the ratings are very high, right? So the ratings are distributed, it's around in between 6 and 8. Okay, perfect. Right, so now let's understand how we can do this rating with the box plot. Okay, so with the box plot we can do it with df dot rating and then plot. Here we can say that the kind is equal to box. Okay, if we plot this, you see here, this says that something like this, but what is the mean of this? You see, so these numbers are the outliers, right? And if you see here, there are few numbers and there are few movies whose ratings are 2, 3 and 4, but most of the concentration is like here. And similarly we can do it if I copy it, or if I copy it and let's say if I paste it here, and if I do like KDE plot, you see here most of the ratings are distributed is in between 6 and 8, right? Perfect. Exactly. So these are the outliers. Then what are these numbers? So this is the minimum, okay, least value excluding the outliers, and this is the maximum excluding the outliers, and this is the upper quartile, right? That's mean the 25% of the data greater than this value, and this is the lower quartile. That's mean 25% of the data is less than this value. That means the 50% of the data is in between these two values, okay? And this is the median, and the median is somewhere around 7 or a little less than 7, okay? Perfect. So this is the way how we do with the box plot, right? Perfect. Now let's do a box plot for the 2 column, okay? For the 2 column, so we can do the df dot box plot, and then we can say the columns is equal to revenue, and by is equal to the rating category, okay? That's the rating category. So the rating category is the bad and the good, okay? But I'm not sure whether we have a rating category in our the data, right? I don't think we have, so this cannot be done, right? Do we have category? No, we don't have a category, right? So what we can do, we can add a new column like category, rating category. So how we can do, let's say if we take this minimum value, okay, if we say here this describe, okay, DEF rating describe, do we have this describe for the DEF rating? I don't think we have, right? So what I'm going to do here, let me tell you, let's say we have a DF rating, describe, okay. So the minimum value here we have 1.9 rating, and 25% of the data is less than 6.2. So let's say if any rating is less than 6.2, we will consider that as a bad movie, okay? Otherwise we will consider that as a good movie, okay? So what we can do, rate in we can do for rate in DF rating, right? If rate is greater than 6.2, then we are going to append it into a new list. That list is, let's say, rating, okay? Rating cat, okay? Rating cat is equal to new list. So rating cat dot append and then we are going to say that good. Okay, else what we are going to do, bad movie. Okay, so let's just run it. Once we have run it, now we have our rating category, that is the list. We have so many bad, good, bad, good, bad, good kind of things. Now what we are going to do, we are going to assign a new column into our data frame, that is the rating category. Okay, so rating category is now our rating cat. Just run it. Now df dot head, you see here, now we have a rating category. Now let's plot this versus revenue. Now let's plot it versus revenue and the rating category. Okay, y is equal to rating category. You see here, now what we have got, there are very few movies which are really very bad, but if you see here, there are so many good movies are into a data set. So this is all about in this video tutorial series, in which we have covered Pandas crash course, and we have done the analysis of the IMDb movies database. I'll be also taking few other video series into about the Numpy, Python and the machine learning. Please do not forget to subscribe this channel so that you can get updates directly into your inbox. Bye bye. Have a nice day.